Hi everyone, it's Miss Costa here, and in this video I'm going to be going through expanding double brackets when surds are involved. Okay, so here I'm being asked to expand and simplify these brackets, and you'll notice there are some surds inside of them. So all I do is exactly the same as I would if I were expanding any old double brackets. It's just you need to be familiar with how to multiply surds. So what I'm going to do is actually set it up in the grid method because it might be a bit easier to see what's going on. Of course, you can just do it whatever method you know best. So you could have done 2 times root 3, like that, so forth. But we're just going to write it out like this. So to do the grid method, I write one surd, one bracket at the top. So 2 and root 5, and I split it into its 2 terms. And then we've got, I'll do it on this side actually, 3 and negative root 5. So I start by just multiplying each term. So I've got 2 times 3, which gives me 6. I've got 3 times root 5, which would be 3 root 5. I've got 2 times negative root 5, which would be negative 2 root 5. And then I've got root 5 times by negative root 5. So remember, root 5 times root 5 is going to become negative root 25, which is negative 5, because the square root of 25 is 5. So that's how I'd do that. Now, if you do it in a grid, it just gives you a bit more space to do working out on the side. And it also makes life a little bit easier because with the grid method, you know that it's the middle 2 terms are going to simplify. So you'd write that out as 6 plus, so I'll just write it out all, but when you do this a few times, you'll begin to notice that you can do shortcuts. So you've got 6 plus 3 root 5, take 2 root 5, take 5. And these 2 terms are going to simplify because they are like terms. Just like with algebra, if you got 6 plus 3a, take 2a, take 5, that would become 6 plus a, take 5. Similarly, here, this would become 3 root 5, take 2 root 5 would be a single root 5. Treat the root 5 as like a little bit of algebra. Take 5. And then 6 take 5 is 1. So that would just be 1 plus root 5. Okay, so we're just expanding them like normal brackets. It's just obviously there's surds involved. So make sure, if this is totally going over your head, watch the video on simplifying and also multiplying surds. Okay, so let's go on to the next question. So once again, I'll do it this way just so that you can see a variation. So I do 5 times 4, which is 20. I do 5 times negative root 3, so it would be negative 5 root 3. I do root 3 times 4, so that would be plus 4 root 3. And then I do root 3 times by negative root 3. Remember, a surd times by itself is going to be its unsurded self, so that is just going to be negative 3. I simplify the 2 middle terms, so that would become 20. And remember, just like algebra, so if you get stuck on this part, just write it out. And instead of the surd, just write an algebra if they are the same surd. Obviously, if they're not, you can't do this. So 20 take 5a plus 4a take 3. How would that simplify? Well, that would be 17, because 20 take 3 is 17. And then negative 5 plus 4 would be negative a. So that would be 20 take away a, take 3. And then that would become 17 take, what am I doing? Sorry, take root 3, not a. So that would become 17 take root 3. And that's how we do that the other way. So let's have a go at the next question. I am being asked to write this in the form a plus b root 5, where a and b are integers. Once again, don't let the wording put you off. All it's asking you to do is expand the bracket. Generally, if you see something, just do what your instinct tells you to do, even if the language confuses you. So what does squared mean? Well, squared means it's everything that is being squared multiplied by itself. So the whole bracket is squared. So the whole bracket is going to be multiplied by itself. So I'd write it out like that. Now I'm just going to do the grid method just because it's foolproof, because you definitely make sure you don't miss any terms. So 3 plus root 5 up here, 3 plus root 5 up here, and then I'd multiply each term. So 3 times 3 is 9, 3 times root 5 is 3 root 5. Once again, 3 times root 5 is 3 root 5, and root 5 times root 5. Remember, whenever a surd is multiplied by itself, it's always its unsurd self. So that would just be 5. And why? If you can't remember that, then just do it like you normally would. So 5 times 5, I can write it like that, which I can write like that. And then I obviously know the square root of 25 is 5. So if this part here confuses you, then just do the working out the long way until you kind of start to recognize it. Then I'd write this out. Now, I know when you get to the shortcut, you can just simplify those in your kind of head, but let's just write it out just for completion of method's sake. So I'd get 9 plus 3 root 5 plus 3 root 5 plus 5. So I would simplify the like terms. So I've got 9 plus 5 is going to give me 14. And then 3 root 5 plus 3 root 5 is going to give me 6 root 5. Remember, you can treat the surd as algebra. So think to yourself, if you had 9 plus 3a plus 3a plus 5, what would that become? That would become 14 plus 6a. But remember, you can only treat it like algebra if it is the same surd. So you can add like terms together. And that's a little whistle stop tour of expanding double brackets with surds. So now it's time for you to have a go. So pause this video and have a go at these questions. Okay, so let's go through the answers. So I won't do the grid method here because lack of space, but 5 times 3 is going to give me 15. 5 times root 3 is going to give me 5 root 3. Negative root 3 times 3 is going to give me negative 3 root 3. And then negative 3 times by root 3 is going to give me negative 3. Remember, a surd times by itself is its unsurded self. And if one's a negative, it's going to be the negative. So collect the like terms over here. 15 take 3 is 12. And 5 take 3 is 2. So that would be 12 take 2 root 3. Okay, next we've got 4 times 3, which is 12. 4 times negative root 5, so that would be negative 4 root 5. 3 times root 5 and root 5 times root 5. So once again, root 5 times negative root 5, you can write it like this if you like. Negative 5 times 5, which would be negative 25, which would be negative 5. So I write that there. Simplify the like terms. So 12 take 5 is 7. Don't know why my brain is freezing a lot today. So 7 and negative 4 plus 3 is going to be negative 1. So that would be negative root 5. So 7 take root 5. And then for the last question, what does squared mean? That just means it's the whole thing multiplied by itself. So I can write that out like this. 3 root 7. 3 times 3 is 9. 3 times negative root 7 would be negative 3 root 7. Same over here. And a negative times by a negative gives you a positive. So that is going to be positive square root of 49. I'll just leave it like that so you can see that you can leave it like that if you want. If it's too much, realizing that root 5 times root 5 is going to get you 5, then just write it as root 25. Whatever works best for you. I'm going to do it this way just so you can see you can do it that way too. So I've got to this part, so I know that I can write that now as, let's simplify what we can. So negative 3 root 7 take 3 root 7, treat it as algebra. Minus 3a is going to be minus 6a, so that would be minus 6 root 7. And the square root of 49 is 7. So my final answer would be 9 plus 7, which is 16. Take 6 root 7. And that's your answer here, there, and I don't know where I wrote the other answer. Oh, there's only 3. Okay, right, so let's move on to where it gets slightly harder, and it's not just a single surd, and it's not a surd that is the same. So this is where the box method is definitely going to come in handy. So I highly recommend, even if you find this stuff easy, when it gets tricky, it's just a foolproof method. So 3 times 4, let's change the colour. 3 times 4 is 12. 4 times root 5 is going to be 4 root 5. 3 times negative 3 root 7, so 3 times negative 3 times root 7. You can write it out like this. So that would give you negative 9 root 7. And then root 5 times negative 3 times root 7. So the surds you multiply, so that would become root 35 times negative 3. So that would be negative 3 root 35. So let's see what we can do. Well, we can write that all out. So that would be 12 plus 4 root 5, take 9 root 7, take 3 root 35. Now, that's quite an ugly looking expression. So let's see if we can simplify any of it. Well, in order to simplify surds, a square number needs to fit into it. The square numbers are 4, 9, 16, 25, 36, so forth. And sadly, none of those fit into any of my numbers. So this is going to be your final answer. So sometimes you just get a collection of terms that can't collect. But that's what we to do there. Okay, next question. Once again, expand and simplify this. So hopefully by now you recognise that squared just means the whole thing is multiplied by itself. So we're going to write it out twice. And then we can put it in our grid again. So we've got 4 root 5, 4 root 5 here. 4 times 4 would give me 16. 4 times root 5 would be 4 root 5. 4 times root 5 again is 4 root 5. And root 5 times root 5. So remember, if you need working and you need to do it this way, that's absolutely fine. 5 times 5 is 25. So you'd write it like that. And then you'd be like, oh yeah, root 25 is 5. So then we can write that all out. 16 plus 4 root 5 plus 4 root 5 plus 5. Collect your like terms. So that's why over here, these are generally going to connect if, gosh, sorry, I've got a really itchy nose. If the surds are the same. So 16 plus 5 is going to give you 21. And 4 root 5 plus 4 root 5 will be 8 root 5. Remember, treat it like algebra. So if it was 16 plus 4a plus 4a plus 5, you know, that would be 21 plus 8a. And one final one before you have a go by yourself. Oh my gosh, I think I might be, I don't know. Okay, so this is where a grid is going to come in super, super handy, because this is a lot of stuff is going on here. So 5 and 2 root 2 at the top, and 2 take negative 3 root 8 over here. So 5 times 2 is 10. 2 times root 2 is going to give you 4 root 2. Remember, always break it down and write it out if you've forgotten, or if you're just like, oh, I don't know what to do. Just write it out, break it down to its simplest form, and then simplify as much as you can. And then we've got 5 times negative 3 times root 8. So 5 times negative 3 is negative 15. So we've got negative 15 root 8. And then we've, oh, this is a nasty one. So we've got 2 times root 2 times negative 3 times root 8. So that would become negative 6 root 16. Okay, so this is clearly going to be a kind of question. Sorry, my nose is just so itchy. Okay, so this is going to require a bit of work. So let's see what's happening. We've got 10 plus 4 root 2. So that's simplified into as much as it can be. Take 15 root 8, take 6 root 16. So it's these two that we're going to want to simplify further. So if you haven't already and you're not sure what's going on here, watch the video on simplifying. So let's simplify root 8. So minus 15 times by root 8. Root 8 can be written as root 4 times root 2. Minus 15 times by root 4 is the same as 2. So that can be written like that. So that would be negative 30 root 2. Again, if this is going over your head, watch the video on simplifying. And then we've got, so let's write that out. So we've got 10 plus 4 root 2, take 30 root 2. And then we've got 6, was that negative? Yeah, negative 6 times by root 16. Well, hopefully we know that root 16 is the same, square root of 16 is 4. So that would be negative 6 times by 4, which is negative 24. So let's simplify that. we've got 10. Take 24 is going to be negative 14. And then we've got 4 root 2. Take away 30 root 2, which will be negative 26 root 2. So don't be scared that this is a negative and it doesn't say in the answer. It doesn't matter, because you could write it as plus minus 26 root 2. So it doesn't matter that it's not a plus. Don't let that freak you out. Okay, so that one was a slightly bit tricky, but hopefully it made sense. And let's have a go now at doing it yourself. So just press pause and welcome back. Let's see how you got on. So 5 times by root 2 is going to give you 5 root 2. 5 plus 5 root 7. And then remember, root 2 times root 2 is going to give you root 4, which is just 2. So that's going to be negative 2. And then negative root 2 times root 7 is going to be negative root 14. And have I missed something? No, there we go. That's why the box is helpful, because you don't miss anything. Root 14, can I simplify that? Are there any square numbers that fit into 14? So 4, 9, 16, 25. Nope, there aren't. So that is in its simplest form. So I've got 5 root 2 plus 5 root 2. So that's going to become 10 root 2. Take 2, take root 14. You could rearrange that in whatever way you want. So you could just say 10 root 2, take root 14, take 2, however you like. Okay, next we've got 4 times 3 is 12. 4 times negative root 8 is negative 4 root 8. Then we'd have plus 9 root 2. Then we'd have take 3 root 16. So you can write it out so 3 times root 2 times by negative root 8 is going to be 3 times 8 times 2 and so forth. You can write it out and break it down like that. So let's see what's going on here. Well, I know I could break that down as 3 times 4, because root 16 is 4. And so all I have to do is look at how I'd break down root 8. So minus 4 times by root 8 is the same as minus 4 times by root 4 times by root 2, because 4 times 2 makes 8, which is the same as negative 4 times by 2 times by root 2, which is why does this appear? Okay, minus 8 root 2. So you've got 12. Take 8 root 2 plus 9 root 2. And remember we said root 16 is 4. 3 times 4 is 12. So that's take 12. So let's simplify. We've got 12. Take 12, which is 0, so it cancels out. Minus 8 root 2 plus 9. So minus 8 plus 9 is just 1. So your final answer is just going to be root 2. Okay. And then our final question, remember a squared just means it's being multiplied. So I've got root 3 plus root 5 times by root 3 plus root 5. So let's change the colour. Root 3 times by root 3. You can do your working over here. Root 3 times root 3 is root 9, which is just 3. And then root 3 times by root 5 is root 15. So you've got plus root 15, plus root 15. And then hopefully by now, but let's just show you anyway, root 5 times root 5 is root 25, which is just going to be 5. So you've got 8 plus 2 lots of root 15. Are there any square numbers that fit into 15? Nope. So that is simplified as far as it can. And that is the end of that. So expanding double brackets, you literally do the same as you would if you were using algebra or expanding double brackets normally. It's just now you have to involve the laws of Surds, and hopefully this makes sense. If not, let me know what bit doesn't make sense and I will do a clarifying video for you.